Hello students, I am back with another video, and that is about the useful concepts in sound and audiometry. And they form the basis of all that you have to study about the hearing tests and especially psychometric tests for hearing. So let's start. Now, what the mind perceives as sound that is not directly equivalent to the physical stimulus that reaches the ear. What does this mean? It means that if there is any sound, for example, of 60 decibels of intensity, and it reaches the human ear, it goes into the ear after the sound waves are converted into electrical stimulus. But what the mind perceives as this sound, as this electrical energy or electrical stimulus, that is not directly equal to the physical characteristics of the sound. Psychoacoustics, it deals with the physical signal of sound and how it is converted into mental perception. So basically, psychoacoustics, it deals with the mental perception of the physical signal of sound. And psychoacoustic studies auditory perception. So psychoacoustic audiometry is that PTA or pure tone audiometry that is commonly done in an ENT clinic or an audiology clinic to get an idea of hearing of the patient and the type of hearing loss if there is any. So first we will discuss sound level. Now what is sound level? There are so many sounds around you, and in order to know that what is the intensity or the level of sound, this is an objective scale that has been developed. This objective scale of sound level is measured in decibels. Decibels. Now, what is decibel? Decibel is a very handy scale. First of all, you should know that. Then, decibel is actually used to express the magnitude of a sound relative to a reference. There should always be a reference value with which we compare the magnitude of that sound. So, how is decibels calculated? If we remember the physics that we studied before coming to medical college, we remember that there's a formula in which number of decibels is equal to logarithm of two intensities, intensity 1, intensity 2. And this formula will become 10 times log of 2 intensities. Or decibels can also be expressed as now 20 times the logarithm of 2 pressure levels, pressure 1 for example and pressure 2. Or there is yet another formula, 20 times log of two amplitudes. Amplitude 1, amplitude 2. So after learning this, you all will ask me that why decibels? Why not some other scale? Why is decibel used for this purpose? So first of all, let me tell you that decibel is a handy scale. It can be easily used to compare two sounds of very, very different intensities. You know, the ratio between the intensity of the softest detectable sound by a human ear and that of the loudest detectable sound or loudest tolerable sound one can hear of is vast, in the order of, see, millions and trillions, ratio 1. Now we can't express sound like this. Like it would be very difficult to express sound level like this. For example, you cannot tell anyone that this sound level is of 1,50,000 decibels or 1,51,000 or 20 million decibels. It would be very difficult for the other person to have an idea. So that is why decibel is used. For example, if you want to know, for example, the intensity, for example, the intensity of decibels of, for example, the intensity of whisper is about 10 to 15 decibels. And if you go into an area where there is an explosion, the intensity of that sound will be too much. It would be around 120 decibel something. So see, there is this wide range of difference between the intensities of both of these sounds. 10 decibels is like 2 times the amount of sound, and then 20 decibels becomes 4 times. Likewise, 30 decibels, it becomes 8 times the intensity. So this is all about sound level. Now let's come to another definition of sound, that is frequency. We all know that a wave, sound wave, is series of compressions and rarefactions. Compressions, rarefactions. Okay. So how it is expressed on a graph? Like this. One complete wave starts from here and it ends here. See, this is one complete wave. Now, frequency of a sound is the number of times the wave is repeated within 1 second. For example, this is 1 second duration. Okay, so y-axis, it actually shows the amplitude of the wave. X-axis shows the duration. For example, this is 1 second duration. In this 1 second duration, how many complete waves they are repeated? 1, 2, 3, 4, and for example, 5. So that will be 5 Hz frequency. Hertz is the standard unit used to specify frequency. So every sound has a different frequency. Some sounds, they are pure tones. Pure tones are made up of only one frequency. Mixed sounds, they are made of more than one. Mixed tones or mixed sounds, they are made of more than one frequency.